Hello everybody and welcome back to another video. I'm SocietySucks and today I'm checking out We Can't Stop Thinking About Wood by Kurzgesagt. I'm not exactly sure what this video is going to be about. Obviously it will be trees and wood related, but what exactly?
Every tree you've ever seen is dead. It turns out the alive part of a tree is just a tiny paper-thin strip of cells trapped between a dead skeleton and dead outsides. Trees are some of the most extreme beings on Earth, with one of the most
So most of the inside is dead?
in nature. On top of being mostly dead stuff, they forge their body out of thin air, they mercilessly crush rocks with acid, and they have an internal negative pressure that would kill you instantly. So how do trees actually work? Let's go back to the beginning. The ancient battle for the sky. For over 1 billion years, the ancestors of plants only inhabited the sun-drenched surfaces of the oceans. Their bodies were thin and delicate
really
and
far
absorbed
back.
water straight through their surfaces, getting their energy through photosynthesis, forging sunlight, carbon dioxide and water into sugar. But about 470 million
eventually
years
they
ago,
went on
they
land
decided
and
to
so
conquer a
on.
hostile alien planet, the land. Like green rugs with ambition, these plant ancestors began clinging to the ground wherever it was wet and damp. But now, with solid ground beneath and no ability to float around, a new dimension became a place of intense warfare. Up. The higher they grew, the more sun they would
sunlight,
get,
of course.
while starving their competition below. Height became a deadly weapon. The battle for the sky had begun. Until now, plants were built mostly from cellulose, which was great for shape but not for strength, which limited how tall they could grow. Over dozens of millions of years of evolutionary warfare, a group of plants developed what...
You know, that's something I've never thought about. How tall can trees actually grow? Is there a limit? Or could they technically just keep growing endlessly if nothing kills them before they manage to reach a certain height?
One of life's greatest breakthroughs, lignin. Lignin is a macromolecule made of ring-shaped structures. It's rigid, tough, waterproof, and incredibly hard to break down. Concrete,
unlike
in a world made of
cellulose.
jelly. It filled gaps between cellulose threads, stiffening and locking everything into place. Lignin gave plants the strength to grow taller and claim the sun for themselves. But of course, now they were competing with each other, which must have been really annoying for them. So, as more millions of years passed, some plants just went all in on lignin and produced more and more of it, becoming stiffer, harder, and stronger. Until one day, around 385
The comment
million
section
years
is
ago,
going to be full
they
of
got
jokes
the
about
biological
stiff
equivalent
wood.
of steel-reinforced concrete, wood. More on it later, but with this magic material, the first trees emerged. Almost immediately, they became the largest living beings alive, shooting up to 20 meters high into the sky, and they only got bigger from here. But this enormous size created extremely hard problems. How do you get
115
water
meters?
from the ground up to the green parts
Holy
that do the
crap.
actual photosynthesis? And how do you get the sugar they produce down to the cells that keep you up there? On the scale of a cell, a distance of a few meters is like you're working in Britain while your lunchbox is in Egypt and your drink in New York.
It would be an
How do you not
incredibly...
So trees
difficult
came up
process
with
to
one of the
transfer all
most
that
amazing
quickly,
ways
no?
any organism grows and became nearly immortal by accident. A conveyor belt of death. Let's slice an ancient tree in half and get to the heart running it all. The cambium, a razor-thin, circular zone just a few stem cells wide. These stem cells grow inward and outwards, turning into two groups of specialists. The inward specialists are on a conveyor belt of death, the xylem. With each new division, it's pushing the cambium outwards, making the tree thicker the older it gets. As the xylem cells mature,
so that's why trees
their
have
lignin
layers.
production goes into overdrive, and they become hard, like a muscle slowly transforming into bone. They begin to hollow themselves out, shedding everything that once made them alive, and then they die. What's left is a corpse, a hard, empty tube. As the tree grows year after year, new corpses are layered on old corpses, forming rings of hardened dead tissue. A graveyard of trillions of plant bones. This is what we call wood. Stacked together, they form a giant network of pipes that stretches the whole length of the tree. This network uses the chemical properties of water and a few other tricks to move it with incredible efficiency. Water molecules are, for a lack of a better word, sticky, like tiny magnets, and naturally cling tightly to each other. When one moves, it pulls the next along with it, like pulling on a rope. In trees, this rope starts in the roots and ends in the leaves that bathe in the warmth from the sun. Here, the heat from the sun evaporates 95% of the water that got sucked into the roots from billions of tiny pores, releasing a constant invisible mist of water molecules around the crown of the tree. This process, called transpiration in plants, creates tension on the rope of water molecules, stretching and lifting the entire column upwards all the way from the roots to the leaves. This pull is so insanely strong that it can lift water over 100 meters, which requires sucking forces equivalent to the pressure.
So I guess that might be a limiting factor in how tall trees can actually grow. I'm just gonna look up what the tallest tree ever was. Okay, so I'm checking the tallest trees on Wikipedia, and apparently the tallest one is a coast redwood in California, which has 116 meters. That's less than I expected. I do also wonder how old a tree can possibly be, because, I mean, technically, if it's just stacking more layers on top of each other and all the ones underneath are dead, technically it could just grow forever, no? So it should be basically immortal?
Dozens of atmospheres, as much as the crushing pressure hundreds of meters deep in the ocean. Nothing humans have ever built comes even close to this power. Even our best machines can't.
I mean,
pull
it's
water
nature.
higher than about 10 meters because the negative pressure required
The
to
one
pull
thing
hard
humans
enough
can't
makes
defeat.
it boil. But the water pipes of trees are so tiny and narrow, almost perfectly airtight, that despite the insane suction pressure inside a tree, water stays liquid and reaches the top. As the tree ages, old xylem cells eventually stop working and fill up with resins and other protective substances. Slowly, they turn into heartwood, a dense, chemically fortified core that's extremely resistant
Soapwood?
to decay.
Heartwood?
The core of a mighty tree. But water is only one half of the story. The sugar produced in the sky needs to be transported to nourish cells down below. And cells from the roots to the leaves need to coordinate and exchange information about damage and growth. This is the job of the cambium stem cells that grow outwards, the phloem, the tiny living part of the tree.
Oh, so this
As
is the only thing
cells
that's
of the
actually
phloem grow
alive.
outwards, they separate into 3 teams and make a brutal compromise. The first group are sieve cells, and their grim fate is to become a living transport system, although living is not exactly right. As they mature, they start to destroy themselves, digest their organelles, and even their nuclei that houses their genetic code. At the same time, they hollow themselves out, connecting to the sieve cells above and below them. This goes on until they're a sad shadow of living beings, a drooling,
so the
living
purpose is
tool
basically
without a brain
to
or arms,
end
unable
themselves.
to support themselves. Only the second group, their companion cells, keeps them alive. They connect with the crippled sieve cells via tiny channels and start maintaining them, sending over energy, instructions, or repairing them if needed. Running along the entire tree, these 2 teams form a tiny and very thin layer of living sugar pipelines and signal cables that stretch throughout the entire body, providing food and information wherever it's needed in the tree. The third team are parenchyma cells, the silent workers of the tree that are carrying out essential labor in the background. Some are like mini pantries that store nutrients, sugars, or water that the tree uses to survive the winter when it's unable to produce
So they're
food.
basically storage.
Others are like mini healers that can repair damage, while some go on the offensive and create toxins and antifungal bioweapons.
Oh, never
to
mind,
kill
they have more
intruders.
functions.
On top of the phloem sits another layer of stem cells. They're producing a second conveyor belt of death, moving outside. Special cells grow from this layer, and as they mature, just like the xylem cells in the center, they kill themselves for the team, turning into a hard guard wall, the bark. Just like your skin, it protects the tiny living layer from damage, parasites, and invaders. So, what is a tree?
Well, plenty of things
The living
can
part of
get
the stem
through the
is
bark
really
and
just
inside.
This extremely thin and tiny layer, a few millimeters thick, sitting on a thick mountain of cell corpuscles, surrounded by another layer of cell corpuscles. The vast majority of the biomass of a tree is dead. This is also why you really shouldn't damage the bark of trees, because while it seems you're only doing a little
You're
damage,
basically killing
you're
the
actually
tree.
killing the living part of the tree. But unless a tree is stopped by droughts, diseases, storms, or a human axe, this system of being mostly dead kind of makes trees potentially immortal. They don't age like we do. In principle, they could grow this way nearly forever. Which is why we still
So
have
they
trees
really are
around that
immortal.
were born when the Egyptians
Kinda.
started building their first pyramid 5,000 years ago. Really, what kills a tree is the world around it. Trees
Just
are
outside
not a real
factors.
biological category, but one of the most successful ideas life has ever had, and many different species developed on their own. These plants won the battle for the sky, solved every challenge that had kept plants small and fragile, and they took over the planet in a few million years. Even today, 3 trillion of them cast their majestic shadows. But we've barely covered half of it.
How would you even count how many trees there are? Obviously that 3 trillion is probably just an estimate, because how the hell would you accurately count the exact amount of trees on Earth? You can't do it. It's like trying to count every single grain of sand.
On top and below, there are the crown and the root system, one building the tree from air, another mining minerals with acid, and involved in complex communications with fungi and other trees. There's so much more to talk about, so we're already working on the next part.
Oh, so this is going to be
Stay
a
tuned.
3-part series.
Trees are
Probably.
truly incredible.
So to sum up this video, the majority of a tree is dead, with only a tiny amount actually living. And any amount of damage can basically kill the tree. So carving anything into a tree is just a bad idea, and you shouldn't do it. And trees are basically immortal. Now, I was aware of the fact that trees could grow to be thousands of years old, but this changes things because they're basically immortal. They can grow forever, unless outside factors destroy it, like a fire, humans, or other elements of nature. And yeah, I mean, they couldn't even cover the whole tree in just one video. They're going to make another video, which I'm assuming will focus on the roots or the crown, and then probably a third video which will focus on whatever the last one is. I'm gonna hazard a guess and say they're gonna make a video about the roots next. And anyway, I don't think there's really much more for me to say here, so hope you enjoyed. If you did, please consider subscribing and leaving a like. If you want to see more reactions, check out this video right here, and with that, I'll see you in the next video.